Kia ora and welcome to video 22 in the series Delightful Differentiation. This problem's a fairly short one. We've got a piecewise function and we're asked for the values of x where the function is not differentiable. All the best, and we'll catch you after the intro music.
Okay, the easiest way to solve this problem is just to look at the graph. We have sine x minus 1 stopping at minus pi, and then sec x continues. We can see that there the transition between the red graph and the blue graph, clearly the y values are the same. When we sub in minus pi into f of x, we get -1 in both cases, but it's pointy, so the transition for the gradient is not smooth, and we can use limits to formalize that. On the other side, well, there's a gap. The secant graph does not equal 2 sine squared x at x equals pi, so that's not continuous and therefore not differentiable. So find the values of x for the function is not differentiable. We need to consider those transitions at the points where the function changes. We also need to consider that the sec function has asymptotes, whereas the sine squared and sine x minus 1 functions have no gaps. Alrighty, so the first thing is consider the points x equals minus pi. Consider x equals minus pi first up. Well, f of minus pi is equal to sine of minus pi minus 1, and that comes out to be minus 1. And then we can also go, okay, sec of minus pi, which is 1 over cosine of minus pi. That equals -1 as well. So f of x is continuous at x equals minus pi. However, when we differentiate these functions, f dash of x is equal to the derivative of sine x minus 1, so cosine x. This is just when x equals minus pi. And then the limit as x approaches minus pi from the positive side of f dash of x will be the derivative of sec x, which is sec x tan x, evaluated at x equals minus pi. Well, tan of pi is, or tan of minus pi is 0, and sec of minus pi is -1, so that equals 0. And as you can see, the blue graph, as we approach minus pi from the right, it's flattening out to a stationary point. But on the left hand side, the gradient, the limit, actually I should really be consistent here and say the limit as x approaches minus pi from the negative side of f dash of x is the same as cosine x evaluated at x equals minus pi, and that equals -1. So yeah, the red graph has a slope of -1, or it's approaching a slope of -1, but the blue graph is approaching a slope of 0, so that f of x is not smooth at x equals minus pi. So therefore f is not differentiable, even though it's continuous. Okay, there's a rapid change of gradient there. Now, you could go through the same motions for the other one, but likewise, x equals... Actually, no, it's not likewise. It's a completely different case. At x equals pi, f of x is not continuous. Therefore, not differentiable. Reasoning, the green function, which is 2 sine squared x, 2 sine squared of pi is equal to 0, but sec of pi is equal to -1. Okay, so that's we've considered x equals minus pi, we've considered x equals pi, and then lastly it's to recognize that there are other discontinuities. There are asymptotes at x equals, what value of x is that? When sec x is undefined, and the secant function is defined as 1 over cosine of x. So when cosine of x is equal to 0, we get undefined. Cosine x equals 0 when x equals plus or minus pi over 2 inside this domain. Of course, there are other values of x, but plus or minus pi over 2 are the values that we want. If we type in x equals pi over 2 there, we can see that's where the asymptote is, likewise for minus pi over 2. Okay, so those values of x are where the function is also not differentiable. Therefore, f of x is not differentiable at x equals plus or minus pi over 2. Cool, so that was the third case. X equals plus or minus pi over 2, x equals pi, and x equals negative pi. All for different reasons, but those are all the values where the function is not differentiable.